Algebra 2. We started the unit on complex numbers last class, and so far what we have looked at is how to identify complex numbers. They have a real part and an imaginary part. How to simplify powers of I. How to graph complex numbers with the real part on the x-axis and the imaginary part on the y-axis. And then the fourth learning target was how we simplify radicals that have I in their answers. We're going to continue the same unit, and the next learning target is on adding, subtracting complex numbers. And this learning target is very straightforward. What you'll need to remember is just to combine the real parts together and then combine the imaginary parts together. So it's basically what looks the same, like terms. Example 1. The complex number 4 minus 2i plus the complex number negative 12 plus 6i. In the first complex number, we can see that 4 is the real part. In the second complex number, negative 12 is the real part. If it's a plus problem, an addition problem, then no signs need to be changed. All you're going to do is bring down your real part, your real number, make sure that you copy down, obviously, the correct signs, and you're going to put them side by side. Then you're going to look for the imaginary parts. In the first complex number, it's negative 2i. In the second complex number, it's positive 6i. Again, because it's addition, you don't have to change any of these signs. So as you bring it down in the next step, you're just going to write negative 2i and a positive 6i, just side by side. Often, they'll use parentheses around complex numbers, but please don't let that confuse you. Usually, parentheses mean multiplication, so really pay attention to the sign that's in the middle. That will tell you what to do. From here, you're going to do 4 minus 12, and that answer is going to be negative 8. Then you're going to put negative 2i and a positive 6i together, and that's going to give you a positive 4i back. And so the answer, the sum of this problem, is negative 8 plus 4i. And you can see my answer is a complex number. This is the real part, and this is the imaginary part. Okay, so with addition questions, they're very straightforward. That's the amount of work you'll need to show. All right, now let's do a subtraction question. Notice again, parentheses are just there to indicate this is a single, like a complex number. Here's the second complex number. But number 2 example is asking us to subtract these two. With subtraction, the first thing I'll need you to do is recopy the problem without parentheses. And because it is subtraction, and there is a parenthesis around that, the minus sign is going to have you change the signs of anything behind it. And so where this is a negative 10, but there's a minus in front of it, you're now going to change that minus negative to a positive, and then you're going to drop your 10 down. In the parentheses, this is a positive 22i, but because there's a minus in front of it, you're going to do the opposite. So it's like minus positive, which is going to change that to a negative 22i. Again, you'll only have to do this step if it's a subtraction problem. Next, you're going to regroup. You're going to find all the real numbers, and you're going to write them side by side. So you're going to do like a negative 25 and a positive 10. Then you're going to look for the imaginary parts. Here's a positive 3i and a negative 22i. You're going to write them side by side. Negative 25 plus 10 is negative 15. Positive 3 minus 22 is a negative 19. And that, of course, is the I term. And so here is my difference. Difference is the word we use for answer to subtraction problem. Here's the difference in these two complex numbers. Notice that the real part in my answer is negative 15 and the imaginary part is negative 19i. Again, addition, all I want you to do is just kind of write the real numbers together and the imaginary numbers and give me an answer. On the subtraction, you need to make sure that you're changing the signs of everything basically in the second parentheses, everything behind the subtraction sign. Notice the minus 10 became positive and the positive 22i became negative. Please remember to do that, because if you forget that step, you'll miss all the subtraction problems. The next learning target is on multiplying complex numbers. There's different types of multiplication. So I went very general here. You can use distributive property. Sometimes that's the best method to use. If it's a binomial, if it has two terms, you want to use the FOIL method, first, outer, inner, last. To multiply complex numbers, you're either going to use the distributive property, or if it's a binomial, like two terms, you can use the FOIL method. All right, example 1. Example 1, I have an imaginary number, 3i, and I have a complex number, negative 5 plus 2i. This is one term. There are two terms in the second parentheses. My job is to take this single term and multiply it by everything in the second parentheses. Please notice that there is not a plus or minus sign in between. So that's indicating obviously we're trying to multiply here. With multiplication, the rule is you can multiply anything together. So you're going to do 3i times negative 5, even though they're not the same type of number, you can multiply them together. 3 times negative 5 is negative 15, and then you'll drop your I down with it. 3i times 2i, well, 3 times 2 is 6, and I times I is I squared. So remember, when you're multiplying, the rules that you've learned in the past, like the product rule, you're going to add powers, and it still is the same. It still applies to imaginary numbers. The next step you'll show is you'll change your I squared over. We learned that in the last set of notes. I squared, every time we see that, we change it to a negative 1. So notice how I'm writing this down. You'll need to show this step. And then you're going to do negative 15i, and then a positive 6 times a negative 1 is just a negative 6. And so the answer to my example 1 is negative 15i minus 6. Okay, question 2. Notice that in example 2, you have a complex number, two terms here, parentheses around it. There is no plus or minus sign in between. Then you have a second complex number with parentheses around it as well. This is a multiplication question. Because it has two terms in the first parenthesis and two terms in the second, you're going to use FOIL for this problem. First is going to be 8 times negative 5. Outside is going to be 8 times positive 4i. 8 times 4 is 32. And because this had the I, you have to drop it down with it. Inside is going to be negative 3i times negative 5. Negative times negative is positive. 3 times 5 is 15. And this term had the I, so we have to bring it down. And then L for last, negative 3i times positive 4i. Negative times positive, be careful with your signs. Negative times positive is negative. 3 times 4 is 12. I times I is I squared. Once you finish that step and you've done first, outer, inner, last, what usually happens is some of them can be combined. So I want you to notice as you kind of scan through the step that these two are like terms. These are both imaginary numbers. Also notice that I squared is involved and we want to switch it over to a negative 1. So the next step, I'm going to drop my negative 40 down. I'm going to add, we're in add mode now, 32i plus 15i. 32 plus 15. That's going to be 47 I terms. Since we're in add mode, we're not going to do anything with the powers. So you also have to, your brain has to switch from multiplication to addition mode. Okay, next I'm going to drop my negative 12 down, and then I squared, I'm going to change that over. Please notice how I'm writing it. I'm attaching it in parentheses. Next step, I'm going to write negative 40. Bring this up here. Negative 40 plus 47i, and then this is a negative 12 times negative 1. That's going to be a positive 12. Now what I want you to notice, you see three terms, this and this. These are both just real numbers, so you want to put those together. When they're like terms, you put them together. Negative 40 plus 12 is going to give you a negative 28. And then you're going to drop your imaginary number down, which is positive 47i. And that would be your answer for question 2. Again, notice the steps that I've shown. First, outer, inner, last. Often what happens is some of them you can put together, which is what I did here to get this term. Always pay attention for I squared, change it over to negative 1, and then just combine your like terms. Okay, we're going to move to question 3 next. On number 3, you see a complex number times another complex number. You're going to do FOIL again. First is going to be 2 times 2. Outside is going to be 2 times 5i, which is 10i. Inside is going to be negative 5i times 2, which is negative 10i. And last is going to be negative 5i times positive 5i. Negative times positive is negative. 5 times 5 is 25. I times I is I squared. In multiply mode, you add powers on like terms. You have 4 terms in front of you. Please notice that this one and this one match. You're going to drop your 4 down. We're in add subtract mode right now. We're going to put positive 10i minus 10i together. 10 minus 10 is actually 0. So instead of me writing 0i, I'm just going to totally leave that out. Then I'm going to drop my minus sign down, my 25, and I'm going to switch I squared over to what it's equal to. And because 25 is in front of I squared, we know that means multiplication. That's again why I'm using parentheses here. Then we have a subtract sign and multiply. PEMDAS always wants us to do multiplication. So this is the same thing as 25 times negative 1, or you can think of it like negative 25 times 1. Either case will work, but negative 25 times negative 1 becomes positive 25. And then you're going to just notice there's no i's even left in this problem. It's just going to be a real number answer. 4 plus 25 is 29. And so sometimes that happens. You're just going to be left with a real number. All right, and then let's check out number 4. On question 4, again, notice there's a complex number, 10 minus 3i. 10 is the real part. Negative 3i is the imaginary part. There's a big power of 2 on the outside. Because there are 2 terms here, it is best if we write down the complex number twice. So anytime you see a problem that looks exactly like this form, please write the complex number down twice and do the same thing we did in the last two examples. It's FOIL. So first, 10 times 10 would be 100. Outside would be 10 times negative 3i, which is negative 30i. Inside would be negative 3i times 10, which is negative 30i. And last would be negative 3i times negative 3i. Well, negative times negative is positive. 3 times 3 is 9. And I times I is I squared. And I see a real number, I see an imaginary number here and here, and then I see I squared, which I need to change. Alright, I drop my 100 down, one step at a time. The two I've underlined in the middle are like terms. We are now in finished with multiplication, so we're back to add subtract rules. If you have a negative 30 and a negative 30, these do not cancel. This example canceled because it was positive 10 minus 10. This is not going to be 0, okay? So be careful with your signs. Always pay attention to what you have in front. So a negative 30 and a negative 30 put together is actually negative 60. So there's negative 60 i's left. And then on your last term, you'll copy down your 9, and you'll change I squared over to negative 1. And so now you're looking at 100 minus 60i, and then 9 times negative 1 is just negative 9. I see two real numbers left. They need to be put together. 100 minus 9 is 91. You'll drop your imaginary term down beside of it, negative 60i. When you have a real and an imaginary number left, obviously you know not to combine those. They are not like terms. So that is the simplified answer, 91 minus 60i. Okay, so today we've done addition and subtraction of complex numbers, making sure we combine real parts and imaginary parts. If it's addition, you need to model exactly what I did here. This problem should be short. If it's subtraction, you must change the signs of everything behind it, so you'll have to rewrite it and then start putting real numbers together side by side, write your imaginary pieces together, and then go from there. If it's a multiplication problem, it can look like any of these. If it has one term, then you just use distributive property. If it has two terms in the first parentheses and two terms in the second, you're going to have to do FOIL. Again, make sure when you see questions like number 4 with a big power of 2 on the outside that you write the complex number down twice, that many times, and you use the FOIL method. Okay, so today we have learned adding, subtracting, and multiplying complex numbers.